Howdy, my name's Mac. I'm with Walter Solutions, and today I want to talk about PLCs. Now, the PLC is the backbone of our manufacturing industry. Almost every modern machine that is produced has a PLC within it. Now, PLC stands for Programmable Logic Controller. All right, now, what does a programmable logic controller do? It's pretty straightforward. Think of the PLC as this box right here. Now, this box right here is the PLC, and what it does is it takes inputs, identifies what it needs to do with the inputs, and then it provides outputs. Simple. Okay, lesson's done. No, it's not over. So, what is an input to a PLC? This can be any number of things. This can be a push button, start. This can be a sensor. This can be another push button or sensor. This can be settings by an operator. Now, all of these are the inputs going into the machine. Now, the machine itself is programmed to look at all of the inputs or the examination of what's happening in the real world and provide an output. Examples of outputs are solenoids. Solenoids actuate either air or liquids of pressure to be able to move something or spin something. Motors. Our PLC can turn motors on. Our PLC can turn lights on. Our PLC can sound alarms. These are all examples of the outputs that a PLC would control. Now, whatever happens with these outputs, typically in a closed loop control system, the PLC is monitoring the performance of these outputs via another input. For example, I have an output that spins a motor. And I want the motor to turn at a speed of 1,000 RPMs, rotations per minute. So I want it to spin at 1,000 RPM, and the PLC sends a signal out to actuate the motor. Well, we need to know what that motor speed is so that the PLC can adjust the output signal to get the right speed. So we have what's called a tachometer sending inputs back into the PLC. This is what a closed loop control system does. It sends an output to an actuator, and the actuator's real-time value is sensed by a sensor and sent as an input into the PLC. Now, how does the information from the input get turned into an output? That's where the programmable part of the PLC comes into play. Most PLCs are programmed with what's called ladder logic, and ladder logic is very interesting because it was originally developed as an easy language to understand from the days of relay logic. Now, before PLCs were invented, we had relay logic. And the way relays work is we have a contact and a coil. Okay? Now, think of this as a dam. Now, the coil on a dam is the hand wheel that an operator would turn with minimum strength. And then you can think of the contact as the huge floodgates that are opening and allow a massive amount of water to pass through it. All right. This is not only super efficient for control reasons, but it's a lot safer because the control circuit and the power circuit can be isolated from one another. And typically in an electrical cabinet, you would separate these from one another. So let's get back to how this plays with the PLC. Now, when I energize a coil, it will close a contact. Okay, when I pass electricity through this coil, it will close a contact and allow power to go through it. Simple, right? Now, all these machines way back when would operate with a monster cabinet the size of this wall with hundreds of relays just chattering at all times in order to run this machine. They were works of art, but they were very noisy, very costly, and took a lot of time to troubleshoot and maintain. So when we introduced the PLC, we took a cabinet that might have been as tall as I am and shrunk it down into a little box this big. Now, ladder logic on a PLC operates very similarly to a relay in that you have what's called a ladder, which is just think of it as a row in an Excel document. All right. And on a ladder, you have this bar, which is always energized. Okay. And then you have outputs right here. Okay. These outputs are typically items that are over here. Now, if I send power straight from here to the output, then the output is going to be on at all times. So, how do we determine when that output is on? We introduce a contact. Okay? Now, this contact, as you can see, prevents power from going from here to the coil output. Now, the contact is an input into the PLC. So for example, if I hit this push button right here, then this contact will close and it will send power to the given output. Now, that's the basic theory of this, and all of these items within the PLC are programmed by a controls engineer. So that's the programmable aspect. We will write ladder logic here so that we can decide what happens when real-time inputs are happening and what type of outputs they should engage. That's essentially the basics of a PLC control system. And it gets a lot more fun and interesting when you recognize that there's numerous machines in a given facility. Now, this is when you have PLCs that can talk to one another, or you have PLCs that can talk to a computer. And this capability, typically through Ethernet signaling and the internet, allows for us to get a real-time view on our computer from our desk or in a cafe in Rome of what's happening in our manufacturing environment. Now, to take it even a step further, with all of the AI capabilities that we have today, we can take this information that we are gathering in our production process onto our computer and utilize AI to not only predict what might happen, but to plan and prevent future problems or plan future expectations of how much we can produce. So what started off as a monster cabinet of chattering relays has since turned into a very sophisticated network of PLCs that can communicate with a computer and give you insight into your manufacturing process from anywhere in the world that is connected to the internet.